Recording is on.
All right, this is Mastering the Lightning Network, session number 8 with the Bitcoin design community and the Bitcoin dev kit community. We're going to be talking about chapter 9 this week, which is about basically bridging the ideas of channel operations as well as HTLCs. I'm going to go ahead just and share my screen to go ahead and bring up chapter 8 or 9 so that we can look at it here. We don't really have anyone to lead for this week, so I'll just speak very briefly about my thoughts on it, and anyone who has questions and comments can chime in. This is definitely the section in the book where it's definitely starting to become very, very challenging for me, and I know I'm going to have to read this chapter again a second time to make sure I fully understand it. Definitely the pictures helped me understand this a lot, so kudos to the designer who put these together. There's a lot of really good infographics in here, I think, that explain the way that HTLCs are passed back and forth between the different channel partners. And I like being able to see how in the previous chapters it was really easy. It was just like single commitments between channel partners. But now they're building these more complicated HTLCs, and they're just you can kind of see in the graphics as like, okay, as this one's created, the revocation secret is passed, so it gets revoked, and then Alice creates hers, and then her previous commitment gets revoked. So you kind of see this happening in the different graphics as it goes down the page. I think there's definitely a lot with the opcodes and all of that form the HTLCs that I don't fully have a good mental model of yet, but it's something I'd like to read again. But I feel like I'm getting the basic gist of this. And one kind of interesting thing I thought from this chapter was just that it seemed that the whole thing is really complicated with HTLCs, but you actually use them even when you're only making a payment between two channel partners, just because it makes the protocol easier to use. It makes it more consistent, so you're performing the same actions, whether or not you're sending a payment across one hop or whether it's across 10 hops.
Yeah, so, I wrote that down as a note too. I thought that was really interesting as a privacy feature that, really protects you even if you're just talking to your immediate peer.
Yeah, absolutely. So that's, I'm going to stop sharing my screen there and just, open up to some, was there anything that anybody just felt like just completely baffled about?
Well, I don't know, you were completely baffled, but I was always a little confused by their infographic, actually. Those boxes, did each one of those inner boxes represent an output? And then the spending conditions for that, or the parameters of that? That confused me a bit.
Yeah, interesting. I get our minds probably have different ways of let me go pull up one of these. So I interpreted these as essentially being different outputs.
Okay.
And the idea, basically, well, I guess the idea is that that is a good question. I don't know. I think that what these symbolize are spending conditions, right? So the idea being that it could, with this spending condition, the revocation key would form the spending condition necessary to spend the 70,000 sats, or the 432 blocks delay would be the spending condition to send it back to yourself. And then the more complicated ones were revocation key to send it to remote, 432 block delay to send it to self. And then I think, actually, to your point, these would actually be an output here, because this says this is going to remote. So I'm guessing that this block...
I think all of these are like outputs, and they just show the first one there where you can see like those 70,000, the condition explained. That's just the script pub key. And so every commitment transaction will have like one output that has a complicated script which they call like this is also an HTLC that like encumbers the payment that you are supposed to get, and the other party gets their payment immediately. So all the white boxes are just outputs, and the left side of the arrow, the left side of the black arrow, the 2 of 2, is basically the input. So at the right side, you can see at the second commitment transaction, there is this new output of 50,200 HTLC number 0. So that's the first HTLC output that Bob added to his commitment transaction. And once he does that, he's gonna revoke his previous commitment transaction, tell Alice about it. Hey, I just revoked it. Now you can add the same HTLC to your output too. Alice will do the same. He will revoke his previous transaction and give the secret back to Bob so that nobody can like go back and publish the previous commitment transactions. They could have like made it like all similar, like equal sized box, but I kind of think like they wanted to show that the script pub key, how does it look like on the side of the party that is making this commitment transaction. So like keep in mind like this will be reverse opposite in the Alice's side, right? So in Alice's side, his 70,000 will be locked by this weird script, and Bob's 70,000 will be immediately payable to Bob. And in Bob's side, Bob's 70,000 will be locked by this weird script, and Alice's 70,000 will be paid immediately to Alice. So they are reverse in these two direction. And then this goes next in the next phases. It goes like how they update these commitment transactions step by step together, so that nobody can like come and do something funny business in between. But they could have like put like equal sized white boxes inside the blue large box. That would have like made a little bit clear.
Yeah, I guess what was confusing to me is I understand like in this diagram for that commitment number 3, the 19,800 plus the 5,200, those equal 70,000. Like we know that the channel, or that we know that the 2 of 2 input was 70,000. So that's what we have to move. That's what we have to subdivide here. But then
no, actually the 2 of 2 input is 140,000. It's sum of Bob's 70,000 plus Alice's 70,000. And what happened when Bob added that HTLC is like Alice's 70,000 got broken down into two parts. One goes in that 19,800 goes into the commitment transaction. That's Alice's side of balance right now, because Alice pays 50,200 to Bob. So Alice's side of balance get reduced from 50,000 to 19,800. Bob's sides of balance is still at 70,000, but Bob now sees an incoming HTLC of 50,200. So once that HTLC will get settled, or like that payment secret gets back from the whoever is getting that final payment from, Bob will like merge that 50,200 back to his 70,000. So then finally the balance will look like 120,200 on Bob's side and 19,800 on Alice's side, keeping the total sum of 140,000 constant.
I see. Right. Now that makes more sense then. Yeah, thinking about that 140 as the input size, that helps. Yeah. And I think he does have a diagram of that at the end where you, like you said, that the HTLC gets merged into the actual channel balance, somewhere in there.
I was going to try and find the...
There it is, 120, 200. Oops.
I'm sorry, did I pass by what you were looking at?
I think, well, anyway, he has a diagram that shows the final after the HTLC has been folded into the main channel balance.
Oh, did you want to go like down to the bottom one maybe?
Yeah, let's just look at that one real quick just to see kind of what the final state is. Sorry, that's going to jump into the chapter, but right. So there, we've got the 120 and the 1980.
And you see the reverse image is on the Alice's side. Like the 1980 is this weird lock, and 120, 200 is like directly payable to Bob.
Yes, that's right.
Yeah, so it's like once they've done passing the HTLC through the different channel hops, and once I guess Alice has successfully gotten the pre-image from Dina, then Alice and Bob kind of like clean things up and they revoke the HTLCs and then send each other just a clean commitment transaction between the two of them. That was the way I understood that.
Yeah, and that makes sense. Yeah, it's understanding that and I guess he talked about that in the last chapter too, about how or maybe even the chapter before, where the agreements are sort of inverses of each other in terms of who gets funded with the block delay, how much is funded with the block delay for the remote party, and how much gets immediately accepted, and how much you get immediately.
Yeah, and it seems like the pattern is like always the complicated part will always on the self side of the balance, and the simple part will always be on the away side of the balance. So for Alice, his self is 19,800, so that's get into this HTLC script. HTLC, by here I mean like this complicated thing. It's also that same HTLC kind of contract, and the 120,200 is away side, so that is like simple P2PKH pub key output. And on the Bob side, it's the reverse of that. His self is complicated and his away is simple.
Mm-hmm. That's a good way to think about it, because that is a bit of a difficult way. It's a complicated way. And I noticed the pattern also like extends for HTLCs too. For like if you are like giving outgoing HTLC, then the pattern will be like something like this, like the HTLC that comes back. If the HTLC fails, then it comes back to you after a time lock. But with revocation key, the other guy can take the HTLC directly, or with a secret, it gets back to the other guy. So it's kind of like the same pattern for HTLCs, and also HTLCs are like reverse opposite for Bob's case and Alice's case. Like the same HTLC that will have like the locks are like the same HTLC. Like let me put it, it's kind of complicated, to like spill it out, and it goes like this. Like the HTLC says like the amount goes back to me, or it goes forward to the away side, and the script that determines how it comes back to me and how it goes to the away side is opposite. If the away side looks at it, for him, it like the same script that goes to me is the same script that goes to him, and his away side is now looks like my away side, and kind of like that. Another thing I just found out, there is this guy called T-Burst in Eclair's project, I guess, and he has this like very good docs of lightning internals, and like if somebody is interested, they can like go and check how the transactions actually look like with the complete, like if you're familiar with Bitcoin transactions, you will be familiar with how this complete transaction looks like with HTLCs and commitments. Probably I just pasted the wrong link. You have to find this one. Yeah, I guess what you said makes sense too, to think about each of those boxes. One of those boxes is, at least for the final on-chain transaction in the situation where it's not cooperative. One of them is the case where someone was cheating, and in the other case, the little box was basically the case where there was no cheating. It's the final commitment, and the number you see for each of those people, like for Alice, you see Bob's number, and for Bob, you see Alice's number. So it's that second box is just that basic split. If everything is done correctly, nobody's cheating.
Yeah, and another thing that was interesting I didn't knew about, and like with some previous calls we kind of like discussed, is like when does this HTLCs gets inside the commitment transaction? Like here they are saying like each time there is a new HTLC update, like there is a new HTLC to add, they just do these steps of creating the commitment transaction for each single HTLCs.
Yeah.
But they might take some time to settle back, but it's not like they are like putting the HTLCs in a pool and then commit a bunch of them together. It's like for each single one of them they are creating a single different commitment transaction.
I mean, they're renegotiating that every time.
Yes,
HTLC.
like all the revocation steps and signing and stuffs, they are
Right.
doing it for each single HTLCs.
That's kind of interesting to me because I would have thought that maybe it was something where you could keep changing or adding something that you needed, and it's not like that at all. It's like a new one every single time, and it almost feels like a conversation, a constant conversation and exchanging these new commitments. It's kind of a hard thing to grasp sometimes.
Yeah, it's a kind of like a live thing, and that's why like it's so much painful, like when your node stops working for certain time and you don't have like updated states and like weird stuffs happen there. So that makes the backup thing also like very complex and complicated thing to do.
He does say that you can have, in one part of the chapter, he says that at any point in time, Alice and Bob may have dozens or even hundreds of HTLCs across a single channel. Each HTLC would be offered and added to the commitment transaction as an additional output. So I think that I think each side has that transaction that they could put on chain that might have hundreds or thousands of outputs, like assuming everything went south, right? Because you have to, if you have 100 in-flight payments routed through your node, you have to be prepared that if your channel partner goes away, that you need to be able to drop that on chain, right?
Yeah, true. And I think like there also they mentioned like the maximum number of HTLC the protocol permits is 438 or something like that, because of this specific issue. Otherwise this commitment transaction will become like so large, it will be violating some of the mempool policies of Bitcoin core nodes, and that huge transaction will not be propagated through the network. So that's how they limit the number of HTLCs that can be added. So after that limit is crossed, I think the node settles it down. But yeah, that's a very scary thing. Like remember, like in order to get the money out of this HTLC transaction, it's not just the commitment transaction. Then you have to get a fund back transaction from the HTLC output to your wallets where you can actually use it. So it's like a double layer of transaction on top of one big transaction. So yeah, it's gonna get like costly in that scenario. Like if you have tons of HTLC that is not settled with your partner, and your partner now goes away suddenly, and you have to settle them back on chain, that can become very costly.
I mean, each output has a signature, and those signatures are the largest components of the transactions. And that, I wonder if that can put you in situations where you really can't get the transaction committed because the fees, the prearranged fees may not even be enough for that many output signatures.
It's possible. I think it's possible. Yeah, right. Probably they somehow like cater for that while negotiating that like fees of the commitment transaction.
Although I guess every time you do negotiate adding a new HTLC with your channel partner, you could probably renegotiate the fee to accommodate. I mean, you still have limits in terms of the size of the total size of the transaction, but I guess as long as you do know what the fees are, I don't recall if that was in the negotiation message or not, renegotiating the fee.
But here it will not help because you don't have your channel partner in the first place to negotiate with, because he's gone. And if you
but every time you create you negotiate adding a new HTLC. I do, before you do have to get those signatures. So,
Yeah, I
prior.
think they negotiate the fee rate at the open channel message. Like when you saying like, "Hey, wanna open channel with me?" Then at the same time, like they the initiator of that channel basically says like, "This is how much fee rate I am going to provide for the commitment transaction," and the acceptor accepts that or rejects that and says like, no, that's like too small fee, I cannot risk that, increase your fee rate, then we are talking something like that. That happens at the start of the channel balance. But I don't think like in such case where your partner is like gone, you cannot like negotiate the fee again, because for that you will need to have the signatures for the new commitment transaction with the new fee rate.
Now,
Well, but
the
you're always
483, sorry to interrupt, the 483 that they mentioned, it also says that they're pending. So I don't know if that helps in terms of how much could be pending. If anything has already been kind of committed, it doesn't count for that number.
Yeah, that's right. I remember reading that too.
There may
I'm
still be issues,
sorry.
but it may be less, I don't know.
I think there is also another setting like the max in-flight HTLC MSAT. In some of the message, probably open channel message itself, it was like it's negotiated. It says like the max amount of like pending HTLC value that I will tolerate. So if that limit is reached, I have like this huge list of pending HTLC, and a new HTLC tries to pass through me, then I will not allow that, and I will not allow that or send that HTLC to my partner until and unless like I settle all the pendings. So there is like pendings, there is like a limit in number of pendings, and also there seems to be like a limit in like the total amount of pendings that a node will tolerate.
I guess those are all things, because they're trying to protect your node so that you don't run into that situation where you can't put actually get the transactions committed to close a channel after your partner's gone.
I was a little curious about the size limit on the HTLC of the 438, whatever size it was, megabytes, whatever. No, it's way too large, megabits, whatever. But the size limit I was curious on, because I guess in the examples I was reading about in the book, it seems to me like there was a distinct HTLC between each node. So if Alice wants to send to Dina, then Alice and Bob have an HTLC, and then Bob and Chan have an HTLC between them, and then Chan and Dina have an HTLC between them. So I guess it just seemed like there was one HTLC per channel, and I wasn't really sure how it was that an HTLC would grow to a massive size to where it couldn't be cashed out on chain.
Well, I think like the massive size problem is coming from like not just a single HTLC, because all the HTLCs will have like a fairly constant size. It will not be too big, but the size will not vary because there is a standard format. But the massive size transaction comes in because each HTLC is a new output in your commitment transaction. So your commitment transaction is like going larger as you are adding more HTLCs which are not settled yet. So in that situation where you have like 100 unsettled HTLC, then you have a commitment transaction of like 103 outputs, and that can be a very big transaction.
Okay, I think I see where I'm not understanding this. Okay, so if I bring up the graphic real quick. So let me repeat this to make sure I understand it. So it seems like this kind of example right here with Alice and Bob is a much more simple example where they're just Alice is sending to Bob. But if this was really a situation where she was sending to Dina, then there would be multiple HTLCs in this commitment transaction. So if this was making another, like, what is it?
No, I don't think that's right. Even if she's spending to Dina, there will be one HTLC corresponding to that payment. Like, as you said, like few minutes ago, like Alice and Bob will have one HTLC, Bob and Chan will have one HTLC, and Chan and Dina will have one HTLC.
Okay.
So each payment in a single channel seems like one HTLC only, and once that payment is satisfied, that HTLC will be absorbed up in the commitment transaction. But what happens when like Alice is like sending to 100 different people through Bob? Like it's not just one Gina, there are like 100 Ginas out there that Alice is routing payments through Bob to. And for each of those payments, there is one single HTLC in Bob's commitment transaction. That's how it's growing.
Oh, I see now. Okay, yeah. So if Alice is paying multiple people through Bob, Dina and Elsie and Frank, and she's trying to go through Bob's channel each time, then every time she routes to somebody completely different through Bob, the commitment transaction with Bob has to be updated. And so there would be the standard to remote, the standard to self, and then the standard to remote. And then this would be the HTLC to Dina, and then there would be the HTLC to Elsie, and then the HTLC to Frank, because she's paying multiple people.
Yeah, correct.
That makes sense.
It's not like even Alice is paying. It can be like somebody else is paying through Alice. Alice is just a router node, so he's just passing around HTLC. So Alice has only one channel with Bob, so Alice only can pass all the HTLCs to Bob. So it doesn't even have to be her own payment also. It can be other people's payment. And she doesn't have any clue like where these HTLCs are going or coming from. She just knows like if I get those secret, then I will get the value of that HTLC, or it will like come back to me after a time lock.
That makes sense. So a channel has kind of like a max, I guess, amount that it can be like, I think somebody said earlier, in flight, it has a maximum amount that it can be routing at a single given moment in time. But once it's done, once the routed payment is complete, then the HTLCs can be pruned and you get a much smaller commitment transaction.
Yep.
Awesome, thank you.
In a real world scenario, the fees would be much, much, much lower, right? That get paid to each person.
What was that again?
Sorry, I must be having problems with my mic, but is that a little better?
Yeah, you're a little louder now.
In a real world scenario, though, the fee that actually gets paid to people would be like tiny, right? Because it seems like.
Yeah, I think so. I mean, he does mention in the book too that some people may not even charge any fee. It's possible to do a routing without any fees, and I think he might have mentioned earlier too that might be done if people are rebalancing their channels. They could. I mean, a zero fee is also possible. But then again, they might charge a high fee if they don't want people routing through them in that direction for some reason.
Yeah.
So that's where I think, I mean, he hasn't gotten into that a lot, but when you get into this whole idea of auto balancing your channels, I think there could be some high fees for that purpose. It's hard to say.
I encountered a 400 sat fee the other day. I of course didn't pay it, but I mean, what to whoever I was trying to send the money to, whatever nodes sat in the middle of that path, one person on that path wanted to charge 400 sats, and I'm just like, man, what a dick. I'm not sure they had a reason for doing it, but
yeah, they were just discouraging, I guess, people from going through them. But I guess you don't really know, because you don't know the fees until you try to attempt a payment through them, and then you find out. Isn't that how it works?
No, I think it's also encoded in the graph, like the gossip data that they send around. Yeah, fee is like the static thing that you set per channel, so other people knows like how much fees you are taking, so they make some decision depending on that.
I guess it's the liquidity that you don't know. Is that right? You don't know how much they're challenged.
Yeah, yeah. You don't know the exact channel balances on each side. You know the channel capacity. You just don't know the channel balance distributions.
Yeah. Okay, that makes more sense. Yeah. One thing I thought was strange, and I don't know if you guys saw this too, is that he mentions in this chapter that the amounts are in millisatoshis, so thousands of a satoshi, and they get rounded up to the nearest satoshi. But I wonder how that works. Like, why would you do that? Like, it's always going to get rounded up to a satoshi anyway.
Correction, the book specifically says rounded to the nearest satoshi. It just says rounded to. I interpret that to be rounding down.
Okay, but even so, it's being rounded to the satoshi. So if you make a payment in a millisatoshi, it's still going to be in the on-chain transaction as a satoshi or nothing, maybe.
Yeah, I mean, I feel like I've had some similar discussions with other people about this. That it's like one of these kind of things where, like, I don't think I would ever pay you a millisatoshi, Steve, like for something. It'd be so infinitesimally small, but I think you see it much more commonly, like, in routing fees and stuff like that. And like, yeah, I mean, there's always a chance that, like, if your routing fee or something is like in a millisatoshi, you might lose some millisatoshis. Like, you might lose some millisatoshis somewhere along the way if you decide you need to close the channel and it gets rounded, down. But, also if you're routing payments consistently through the node, those millisatoshis, you stack millisatoshis.
Mm-hmm.
And when you stack millisatoshis, eventually you have a satoshi. So it's like if you're routing millisatoshis all day long, then I think that for high traffic nodes, it kind of adds up eventually. That would be my guess, though.
I guess, yeah, maybe what I was thinking about it wrongly was that you've rounded it to the satoshi when you actually create your commitment transactions, but you're doing the bookkeeping in another data structure somewhere where you keep it in millisatoshis. So I guess that's where you can combine those millisatoshis into a satoshi in your data structures when you make your final, like, you do like a cooperative close, for instance. That's maybe where you've kept track of all those millisatoshis. It's not in those intermediate signed transactions necessarily. That makes sense.
That actually is a good question, though. What does that accounting look like?
Because they must keep a parallel structure. Like, you're not just keeping these signed intermediate transactions. You're probably keeping a data structure somewhere where you're keeping the balance down to the millisatoshi. So then because eventually at some point you are going to both agree on a final cooperative close or something, and then you've kept it down to that level. You could potentially combine all those millisatoshis together.
Yeah, because I see what you're getting at. Because, like, if you obviously, anytime you do anything with your channel partner, you need a new signed commitment transaction and a revocation secret and all that. So anytime that commitment transaction gets signed, it's going to get rounded down. But obviously, you want to be able to cash those millisatoshis out eventually. So is there, like, I don't know, maybe does a Lightning node have, like, at the software level, is there like some kind of database or whatever that keeps like a different metric of accounting or something? Or maybe there's something else we're missing here. I don't know.
Yeah, that maybe.
Also, like, has anyone like tried like sending like 2 millisatoshis somewhere? I never tried. I want to see what happens, because that's a good question, because in HTLCs everything's gonna be in satoshis. So like, if I send like to somebody 1 millisatoshi, what does that HTLC look like? I am not sure.
Even if you send 1.01, like it's like a satoshi and then some millisatoshis, like there might be a minimal limit, but you could still have say the minimal limit on an invoice is a satoshi, you could still maybe send a satoshi plus a millisatoshi, in the same issue you just mentioned.
Yeah, true.
Ran across something. Somebody tried a small transaction. I don't know if I'm getting it right, but look, it says inbound 10 sats, outbound 10 sats, and then it says a fee 2 millisats. I don't know if that's pretty
As a
tiny.
fee. Okay.
Yeah, that's what the fee though.
Yeah, I think
Yeah.
that's what Stefan was sort of saying, is maybe maybe it primarily comes up on the fee side as opposed to the, but it's still, again, it's still eventually is going to go on chain and it eventually going to get rolled up or rolled down into a Satoshi. Yeah, I don't know. Because again, I think it may just fall into the implementation details. Because you eventually have to settle that channel on chain, and then how does it? You would have had to keep track of all of your balances in millisatoshis, not just in satoshis. So
maybe as the price of Bitcoin rises, maybe millisats will become a more important, important unit of account. I mean, one thing I've been thinking about is there's already people talking about layer 3 solutions, and there's Impervious, I know, is one of them, and I think there's probably several others. And I think some people have built interesting stuff on there. Like I think John Cantrell built something on Impervious. I think it was like kind of like an AWS Lambda, but it was like you have a piece of code that you want to run in the cloud, and you pay for it over the Lightning Network. So every time you make an API call to this program, then it you pay in Lightning, and then it gives you the output of your API call. I think that's what it was. I may be misunderstanding it, but regardless, you can imagine a future maybe where you have an API that needs to be paid for, and like typically some services may charge for every API request. So you can have an API that's paid for over the Lightning Network. And so, an API call costs a very tiny amount of millisats. And as the software you write is making requests to this API all day long, the person who built the API is, actually being, rewarded quite well for it. And as the consumer or as the software developer using the API, that's a really cost-effective way to just have to pay on the millisats for the service.
Yeah, that's another good example too, is that you're paying for an ephemeral service. You're like, if you happen to lose a couple of millisats because maybe that last one rounded wrong, it's not a big deal either. Like you're missing maybe the 2 millisat payment for a single API call. That's probably also not gonna, you're not really out anything at that small amount. So it becomes insignificant, but you still have to account for it. Like if you're doing 2,000 API calls and each one's a couple millisats each, then you've at least got a couple sats for it. That's still a small amount though to be committing on chain as an output. So you'd probably want to keep that channel open a while to make it worth closing. But yeah, it's interesting. Definitely people are thinking ahead in terms of things costing more or Bitcoin being worth more.
It also will mean like if somebody has like less than 1,000 millisats, then like any number less than 1,000, like 999 millisats, then he's not getting paid, right? Because that cannot be converted into the minimum number. Yeah.
Right. Yeah, that seems to be the case where, but again, if it's primarily routing fees or API calls, or I think with John Cantrell's thing, there's sort of an oracle. It's like I think the API calls are sort of like an oracle bit of data, then you're probably not going to sweat it too much if you miss a couple of sats or almost a sat. I guess at most you could lose would be almost a sat. So that's, at least at this point, not too bad.
Yeah, I think the main application comes from this idea of like streaming money, right? Like we want like very tiny pieces of money, and we want to create this constant stream so that like at each instant of time, the unit is like insignificant, but over a certain amount of time, like for 2 minutes, 3 minutes of streaming, now you are talking about like 2.5 sats or something like that.
Yeah. Although there is an issue that comes up. This has come up in phone network protocols too, where if you might spend more computing resources just accounting for those small amounts than you would really ever get for them. That there's issues like that. Like if you charge by the packet, all of the database work to keep track of those payments actually costs you more than just doing it as a bulk rate. But
Right. Yeah, that does make
people
sense.
will figure that out, I guess, just in terms of what's economical. Like you might say every 1,000 calls you're going to charge or something like that.
I think Alexa had a comment a minute ago.
Oh, thanks, Stephen. I was just wondering, like, on this layer 3 thing, what does it mean? I mean, what would it enable people to do? Is it just about data on a network? Like, I cannot imagine it, and I don't know. Maybe.
The one application I'm aware of is this sort of Oracle application. So imagine it this way, as my understanding is that you make a contract with somebody and you say, if this condition happens, like if the price of oil goes above $1,000 a barrel, then the Oracle is going to produce a signature. They're going to sign some data. And then if it's below $1,000 a barrel by a certain date, it's going to be a different bit of data signed by this Oracle. And you make a contract, I make a contract with you betting one way or the other, or it could be a sports game or something. And then the Oracle doesn't need to know anything about our contract. He just, when the time is right, creates this little signed bit of data. And then we can plug that. It's a little bit like these HTLCs. We can plug that little signed bit of data or that particular secret into our contract and have it settle for you or settle for me in terms of sort of winning that bet. So I think in terms of this API, paying for APIs, one of the ways you could fund an Oracle like this is you could say, well, if you want to get my little signed, encrypted, or my little secrets from me, you're going to just have to pay by the request, potentially. So that's maybe oversimplifying. I might be missing some details there, but that's the general gist of it, is that might be that might be the kind of API calls. Or I think like Stephen was saying, it could also be just something more similar, like a more traditional, like I'm a podcaster and you're paying me as you stream my podcast, like every minute to get a new key to download that stream of data, you're sending me a payment. And I'm giving you the keys on a regular basis through that API.
Okay, so let me see if I kind of understood this. So layer 1 is Bitcoin, right? Layer 2 would be Lightning that works on Bitcoin, and anything layer 3 would be what uses Lightning in order to provide a service or some kind of a thing like that.
I think so, like application layer. Actually, that's a good question. How did he does he have an application layer in his diagram in the book? Forgot if that was part of it or not.
Oh, you're talking about in Mastering Lightning?
Yeah, because he does have that sort of context diagram.
Just it ends at the payment layer: network connection, messaging, P2P, routing, payment.
Okay. Yeah. So, yeah, what you call layer 3 is probably open to debate, but I think it's not unreasonable to say, this sort of Lightning-enabled applications could be sort of a layer 3.
That's kind of the way I see it. I'm Alexa too, that it's like basically standards for building applications that use Lightning. I don't know, what that looks like from a design or user experience perspective, if anything, because these sorts of things are probably, I imagine, going to be very kind of under the hood technical things. I mean, like the way I think about it is that, like, the internet, we have the base layer, TCP/IP for just sending packets across the internet, right? And but then that's a very fundamental layer, but it's not like easy for us to use, right? Then you build something on top of that, like HTTP. It's another protocol, sits on top of the internet, and then suddenly using that, you can build websites. And so then you see the proliferation of the World Wide Web in the 90s. And then once the web becomes the norm and everyone's, looking at websites and things like that, then you start having like companies building layers on top of that, like you might argue like an API or something that Amazon builds. Like S3 is like a storage, and a lot of websites we use Amazon S3 for storage, and it's like I mean, it's closed source. It's a company, but you think about it like it's a protocol that pretty much anybody who has to deal with any kind of internet connected application nowadays needs to know how to use a service like that. So it's like another layer that kind of, I guess you could say, extends the functionality of the internet, depending on how you look at it. So yeah, I see it as just kind of another set of protocols or applications that can use Lightning.
I mean, some of these layer 3 protocols too, like the one you mentioned with John Cantrell, his gun project, and then SureBits has some very, SureBits is doing something similar in this area, where it's really more like a smart contract using an Oracle. So that is sort of like you were saying, it's another type of application built on top of these other applications. It doesn't necessarily even need to be built on Lightning. It could be just another kind of smart, like Lightning is a kind of a smart contract protocol itself on top of layer 1 Bitcoin, and these potentially, by providing different kinds of contracts through a third-party Oracle, it could be layer 2 even, or layer 3, because they're able to do sort of a whole different kind of financial thing with these like betting applications or contract for difference sort of futures market sort of thing that is still built on layer 1 in a way, but with some of these layer 2 concepts of signed bits of data that complete the contracts from anonymous oracles. It is pretty interesting stuff.
I also find it like interesting, like how in these other protocols, say for example, these betting protocols like DLC or some kind of like atomic swap protocols, these HTLCs are still like kind of like fundamental contracts on top of which they built on. It's not just only for Lightning. This HTLC seems like kind of like this general thing where that statement, like if some secret revelation happen, then money goes to you unless or after some time out, money comes back to me. And this is kind of seems like this fundamental contract, and people are using it in different ways and coming up with a lot of applications. And Lightning is just one or the first application of that contract. It seems to me like in that way it's developing.
Yeah, actually, you could almost think about the payment hash part of Lightning. The person getting paid is sort of the oracle for that contract. They're providing that secret that enables this protocol to work, to complete, for instance. While a betting or a sort of a financial atomic swap thing, the oracle is sort of more a third party involved, providing these regular secrets to complete people's contracts without even knowing what the contracts are about. In the case of Lightning, the person is involved directly, but in the case of the oracles, they're providing these secrets potentially for a fee, but they're completing people's contracts where they don't even know anything about those contracts. They're just providing some regular agreed upon data in a certain way. So yeah, it's pretty fascinating. I think we've just seen the beginning, just beginning now to see it. And then just like Lightning is going to benefit from Taproot, and these contracts are going to get easier to use and more powerful, it's going to be the same for these other ones. In fact, even more so probably, because they'll be able to encode a lot of different stuff in those signatures. Yeah, so
we're getting close to the hour here, so I think I'm going to go ahead and disable the screen recording for this call. But we can continue to hang out, and for anyone watching this, just keep an eye out for the schedule for next week's call. Okay.